Today, we're going to start the last part of AP Stats, which is called inference. What is inference? Inference is drawing conclusions that go beyond the data at hand. Okay, there's two main types of inference that we're going to look at. One is estimating a parameter, which is what we're about to do today. That's confidence intervals. And the second type is testing a claim, which is what we'll do in the next chapter, significance test. Okay, what is the scope of inference? What can we do with inference? Well, if I had random sampling, then I can generalize my results to the entire population. If I had a randomized experiment, then I can generalize cause and effect. All right, today we're going to look at section 8.1, confidence intervals, the basics. What is a confidence interval? A confidence interval is something like, we've all heard before when we take a poll, you've heard polls, what's your approval rating of this particular candidate for governor or this particular person that's the president? What's your approval, do you approve or disapprove of what he's doing? And you get a poll, and in the poll you get a range of numbers. They'll say, 47% approve of what the president's doing with a margin of error of 3.8%. And that's a confidence interval. Okay, so let's look at some basics about confidence intervals. What is a point estimate? A point estimate is the value of a statistic that provides an estimate of a population parameter. So the point estimate is the percentage you get when you do your survey. Okay, it's that 47%. All right, we want low bias and low variability, which means we're either going to use p-hat or x-bar. For confidence interval, a confidence interval is an interval of plausible values for a parameter. Confidence interval is the interval of plausible values for a parameter. Okay? It's calculated from the data. How we calculate it is the point estimate plus or minus the margin of error. And remember, plausible does not mean possible. Plausible does not mean possible. Plausible is any reasonable or believable value based on the data. Okay? All right, what is a confidence level? Our confidence intervals have to have a confidence level. What is a confidence level? It gives the overall success rate of the method for calculating the confidence interval. Okay? Again, it gives the overall success rate of the method for calculating the confidence interval. All right, so that means if I have an 80% confidence interval, then 80% of the time, my interval is going to capture the true population parameter. It doesn't mean 80% of the time the parameter is going to be in there. The parameter is where the parameter is, and that doesn't change. It just means 80% of the time, the interval that I calculate is going to contain the parameter. 20% of the time, it will not. If I calculate a 90% confidence interval, then 90% of the time, I'm going to capture the true parameter, and 10% of the time I won't. Okay? The lower your confidence, the smaller your interval. The higher your confidence, the larger your interval. All right, margin of error. What is margin of error? Margin of error is a range of values above and below your sample statistic. It's that plus or minus that we add at the end. Okay, why include the margin of error? Because the statistic will vary from sample to sample due to chance. Okay, the margin of error covers that chance variation. All right. Please feel free to pause at any time to write stuff down and then push play again when you're ready to go. All right, how do we interpret a confidence interval? Very important. One of the things we have to be able to do on the AP exam is to interpret a confidence interval. So here's how we do that. We are blank % confident that the interval from blank to blank captures the true blank. We are C % confident that the interval from blank to blank captures the true parameter and context. Okay? So, this is how we're going to interpret a confidence interval. Please do not try to get creative with this. Please put a star by this and interpret it exactly the way that I've written it here, because this is how the AP test wants you to interpret it. Okay? The next thing we're going to look at is interpreting a confidence level. Interpret a confidence level. If the sampling process was repeated many times, approximately C% of the resulting confidence intervals would capture the true parameter and context. Okay, so that's how we interpret a confidence level. If the sampling process was repeated many times, approximately C% of the resulting confidence intervals would capture the true parameter in context. So, when I was talking about the approval rating of the president at the very beginning, and I said 47% approve of the job that the president's doing, and say it was a 95% confidence interval, but I would say if the sampling process was repeated many times, approximately 95% of the resulting confidence intervals would capture the true proportion of people that approve of the job the president's doing. And that's how you interpret a confidence level. Okay? All right, let's look at an example. See if we can do this. All right. Example. According to www.gallup.com on August 13, 2010, the 95% confidence interval for the true proportion of Americans who approved of the job Barack Obama was doing as president was 0.44 plus or minus 0.03. Interpret the confidence interval and the confidence level. Okay, so we're just going to use the fill in the blanks that I just gave you to do this. We are 95% confident that the interval from 0.41 to 0.47 captures the true proportion of Americans who approved of the job Barack Obama was doing. That's how we interpret the interval. If the sampling process was repeated many times, approximately 95% of the resulting confidence intervals would capture the true proportion of Americans who approved of the job Barack Obama was doing. Again, it's just fill in the blank with the confidence level and the parameter and context in the interval. All right, let's look at another example. A large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day, on average, the company provides a pedometer to 50 randomly selected employees to use one 24-hour period. After collecting the data, the company statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. Interpret the confidence interval. So again, we are 95% confident that the interval from 4,547 to 8,473 captures the true what? The true mean number of steps taken per day for employees at this company. Okay? That's how you interpret the confidence interval. What is the point estimate? What is the number that was used? What was that 47% when I said 47% approval rating before I did the 3.8 margin of error? That 47% was my point estimate. So what's the point estimate that I add my margin of error to here? We don't know. We just have the interval. So to find the point estimate, you take the lower part of the interval and the upper part of the interval, add them together, and divide by 2. So that gives me 6,510. That was the mean number of steps taken by these 50 people at this company. Now to find the margin of error, just take the 8,473 minus 6,510, and that gives you 1963, and that's your margin of error. That's what you add to the 6,510 to get 8,473, or subtract from 6,510 to get 4,547. Excuse me. Recent guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? Explain. Yes, there is evidence this company is not meeting the guidelines because all values within my interval are less than 10,000. And that's how you would answer that question. Okay? All right. So what's the formula for calculating a confidence interval? It's a statistic plus or minus the margin of error. And the margin of error consists of this thing called a critical value and the standard deviation of statistic. We'll go more into critical value next time. How do we reduce the margin of error? All right, how do we reduce the margin of error? The margin of error, there's a couple ways we can reduce it. We want to make it smaller. The first thing we can do is lower our confidence level. The less confident we are, then the lower our critical value will be, and the smaller our margin of error. What's another way we can lower the margin of error? We can take a larger sample. By taking a larger sample, we reduce the standard deviation, and that makes the margin of error smaller.